let's talk about refractory periods. Let's say this chart, this action potential chart, would correspond to this area. This one corresponds to this area. And let's say some current is able to enter from the dendrites and reach the axon hillock and able to reach the threshold. So we can expect to see from the resting memory potential to the threshold and then peak at 30 millivolts once we can see that a lot of sodium ions are entering the area. So then we can expect to see huge depolarization around this area, positivity or positive voltage, and that it spreads to the right side as well. So then from its resting memory potential, it goes up to its threshold and then again peaks because a lot of sodium ions are coming inside. But let's take a look back at number 1, at the area 1. We can expect to see a lot of potassium ion leaving the axon. And as such, we can see that depicted here as it repolarizes all the way down to back to negative 70 millivolts. We can also expect for this area to become negative. And so at this point, we can see that it has a right at negative 70 millivolts. We should note that sodium channels have this odd function where they are either active or inactive. At this point, they're inactive. And so no other action potential can occur at this point because the sodium channels are inactive and you need sodium channels to be active to be able to create an action potential. So this area is called the absolute refractory period. However, once it goes further to hyperpolarization and attempts to head back to resting memory potential, at this point, this is called the relative refractory period because sodium ion channels are now active. However, it will take a huge stimulus, a huge current, to be able to create an action potential because at this point, let's say we're at negative 90 millivolts instead of our resting memory potential of negative 70. It would take us a 40 millivolt depolarization to reach our threshold. And if you ever questioned why propagation only goes one way, well, this is the reason why. Because of the absolute refractory period, it prevents any more depolarization to basically back propagate through the axon. So then it only has one way to proceed.